In this final video on vacuum infusion, we will analyze the data collected from the vacuum infusion in the previous video. After a brief introduction and theory review, the lab assignment will be introduced. Calculations and analysis involving permeability, flow theory, and the flow front will be explored in this video and in the lab assignment. During the lab, it is important to mark the vacuum bag with several evenly spaced lines that represent distance measurements. Record the time it takes the resin to reach each line. These data points can be used to plot the flow front versus time graph. They can also be used to calculate permeability. This time-lapse shows how the data collection should take place during the lab. If you do not have a dataset from the lab, feel free to use the dataset provided. Permeability is a measure that quantifies the ease of resin impregnation into a fiber matrix. Its value can be unidirectional, bidirectional, or multidirectional, depending on each scenario. Permeability is analogous to conductivity in an electrical circuit. The permeability value can be used to create simulations and models and allow engineers to optimize performance parameters. Let's review the important equations and laws governing the vacuum infusion process. Flow through porous media is governed by Darcy's law. The equation is shown on screen. The superficial velocity measures the rate at which resin flows through the material, accounting for porosity. Shown on screen is the volume flow rate equation. By relating these three equations, we can derive the time to fill a rectangular laminate. Using this equation, we can substitute the slope of the flow front position squared versus time graph to solve for permeability. It is important to note that the entire derivations were shown in more detail in the vacuum infusion theory video. Furthermore, these specific equations only apply to flat, rectangular panels. Complex shapes will require more elaborate equations. Now that the specific equations behind vacuum infusion have been touched on, you can try the lab activity for yourself. If you do not have access to your own dataset, use the dataset provided. Feel free to pause the narration and attempt this activity on your own. In this solution, we want to use metric units. So the first step is to convert the original flow front versus time data from inches to millimeters. After this, a simple flow front versus time plot can be graphed. Next, plot the flow front squared versus time graph. Make sure to record the slope of this value. Use a linear trend line to get this slope value. The next step is to find out the specific values of viscosity, fiber density, and fiber areal weight for your given infusion parameters. These values can be found on material data sheets. In our case, these parameters are shown on screen. Using these values, the fiber volume fraction must be calculated using the fiber volume equation. Following this, the matrix volume fraction can be easily calculated, as the matrix volume fraction is simply 1 minus the fiber volume fraction. Finally, using these values alongside the equations shown earlier, the permeability can be found. Here are our final results from the lab assignment. As you can see, our simple flow front versus time plot is logarithmic, and the flow front squared versus time graph is linear. Our final permeability value is 1.89 times 10 to the negative 11. Imagine you wanted to calculate the permeability of two identical parts. You would find that the individual permeability and flow front versus time values may not match up perfectly. There are many reasons for the difference in these values. However, the most common reason for this is experimental error. Each time the vacuum infusion process is executed, the environmental and human errors are greatly varied. The room temperature affects the temperature of the resin, hence the viscosity of the resin somewhat depends on the ambient room temperature. Vacuum infusions conducted during the winter versus in the summer can have wildly different results. It is important to account for these temperature differences. A heating pad could be placed along the outside of the vacuum bag, so that a constant temperature can be maintained during the vacuum infusion. Another source of experimental error is from air leaks in the vacuum bag. If the vacuum bag is not airtight, the vacuum pressure on the resin will not work as intended. Resin can leak out of the bag too. If the leaks are big enough, the entire process can be compromised. These leaks also make it difficult to measure permeability as the flow front speed is varied. Please note that permeability has been notoriously challenging to measure. There have been attempts to standardize the experimental procedure, but there's currently no agreed upon method. These attempts to standardize the procedure to calculate permeability have been outlined in 2 research papers. One of the paper's main reasons for the difference in permeability values is due to operator error, so don't worry if your answers do not match up perfectly.
Thanks for watching. To see more virtual labs and learn more about composite materials, make sure to subscribe to the CKN YouTube channel.